Okay, so now we will read and summarize data into R. So first we'll start by opening the script. So we will um, download the Psych package, and then let's run that. And then the Psych package is downloaded, and now we will actually load the Psych package for use. Okay. Psych package is loaded, and then now we'll now we will load the CSV file into R. We do header equals true. That just means so R doesn't read the first row as a part of the analysis, so just our header. Then we could load in our data on the side, the data is loaded in. Click on that and see all that data is loaded. Oops. Click on here and then you can see the variables that we have, the ONA code, title, job zone, and conscientiousness. And now we will find the or compute the mean and the standard deviation. Go ahead and run that. On the output, we can see we have 879 cases. The mean or average is 4.39, and the standard deviation is 0.27, which is pretty low, and that means the points are close to the mean, not super spread out. The median, which is the middle point, trend mean, if we take off some data points from the ends, that's the new mean. The MAD value, which is the standard deviation value. The lowest value, which is 3.3. The highest was 4.96. Subtract those and you get the range, 1.65. And then our skewness is negative 0.66. Basically means that some of the data is mostly to the right side, and the tail end is closer to the left. And then we have 0.37 kurtosis, slight positive kurtosis, so just a little bit is kind of leptokurtic. And then standard error would be 0.01. And then next we could see the histogram of conscientiousness. Better run this. So similarly, what I said earlier, now this is a visualization of the distribution. Here we can see, as you said earlier, this skewness is negative, so a little bit of, or some of the data is more to the right compared to the left. A little bit of kurtosis, but that's kind of hard to see with they just made point 0.3. So next we move on to create a QQ plot. And then we can also run the QQ line. So we see the line of normality. Go ahead and run these two. Here we can see a lot of the midpoints are closer to the line. However, the endpoints are kind of deviating from it. So we can see some outliers here up to here. And then the deviation kind of starts from like right here. And then it deviates a lot out. So looking at the QQ, we could say it's not normal. Maybe not the most deviation, but just a little bit. And then we can move on to creating the Shapiro-Wilk test of normality or conscientiousness. Go ahead and run this. We'll see that the statistic is 0.97, and um, the value, the closer it is to one, the more normal the distribution would be. So 0.97 is a little away from one. So it's possible someone could say, well, the normal isn't normally distributed. The p-value is also very, very tiny. So we could, well, based on this test, it says that we can't assume normality. And so moving on next, we generate a box and whisker plot for conscientiousness, but we will see the different levels of the job zones. This symbol represents the job zone that we want, or the job zones. Go ahead and run that. And then here generates the box plot with job zone 1, 2, 3, and 4. The trend that you can see here is the median increase as higher the job zone goes. So number of the jobs on one would represent little preparation, and jobs on five would represent the most preparation. So the trend that you can kind of see is, or you can kind of say, could be that conscientiousness increases um, the more preparation you need for a job. And so let's say jobs on one and two, the variation's kind of big between the interquartile range, and it kind of gets smaller between three, four, and five, the more preparation that you need. And so there are some outliers for job two, and just a couple outliers for four and five, but um, it doesn't look like how it doesn't look how these outliers really affect um, how these come out on the box plots. And yeah, that's it.